Now, depending on how much you like graphing, you might already be looking at this method of solving linear equations and flailing your arms in the air like the infomercial guy and saying, there's got to be a better way. But maybe you like graphing, right? Maybe you would be happy solving equations this way forever. Let me show you an example of a typical system that might come up in an application. 0.07x plus 0.05y equals 800. X plus y equals 15,000. I somehow don't feel like this is the right scale to graph these equations. All right, this first equation is going to have intercepts 0, 16,000 and 11,428 and 4/7, 0. Are you keen to graph this point? No, nor am I. The second equation is going to have intercepts 0, 15,000 and 15,000, 0. So whatever graph we have, our axes are going to have to extend out to around 16,000. But wait, you say. I'll use a computer to do it. Fair enough. Here's that graph on an appropriate scale. And we can see that these two lines do cross somewhere in here. If we trace, we can even see about where that is. About. Do they cross here or here? It's hard to see. We've already done enough monkeying around just getting these equations into the graphing calculator, right? We had to solve for y in both equations. And now we're going to have to do more monkeying around to figure out where they cross. And that's still just going to give us a decimal that's about right. What we really need is some algebraic method where we don't need to do all of this screwing around, where we can just manipulate these equations and get a solution. And that's what we're going to see tomorrow.